All right, I think what I'm going to do, because I'm looking at the time, and I know I said we were not going to go past 7, and I still want to achieve that for sure. Is I'm going to kind of combine the other two segments of tonight together, and maybe maybe give you a little bit of time to look through them, but maybe more sort of answer questions as we go. But the good thing about what the other two things tonight is that they're all basically the same thing. It's just that each one does a different something. But once you understand how the programming or how the code blocks work in Scratch, at that point, it's really all just about learning what each of the blocks does. And in general, Scratch is pretty good about labeling the blocks with names that make sense. They're not using, in most cases, really specific programming language kind of terminology. If something changes a costume, the block says change costume. If it's move it somewhere, it says move to. So once I think you get an idea of how the programming blocks function, I think we can move through sort of what each block does pretty quickly. So I'm just going to kind of combine the looks and the event blocks pieces together so that we can still get out of here in about within 40 minutes or so. So jumping back over to my friend the Scratch Cat here, we've been looking at costumes. What I'm going to do now is, being clicked on the Scratch Cat, is I'm now going to click on the code tab, and I'm also going to minimize this so I get a little bit more space here. So when you click on the code tab, this is the programming piece. And this is where I know in a lot of your comments this week, there were several people who said, like, this seems like an awful lot. I don't know, how this would work into my classroom because we have to, we'd have to have all the time to teach it and everything else. The idea behind Scratch is it's a programming language. So you can use this either, I'm going to teach this platform to my students so they can create things, or you can use it yourself to create things which then your students can interact with, or it can be used as a platform for, just teaching what programming is about. So this can be used in a lot of different ways. And one of the things that I think they've implemented really well is the whole idea of how you program in this. And the whole idea is that it's basically like Lego bricks, where you just stack Lego bricks together, and each of those bricks does something for that sprite. So the code is always attached to a sprite, and whatever that code says to do will be what that sprite does when that code runs. So when you open up the code tab, you have all of the coding blocks that are available, but they color code them into kind of categories. So all we're going to look at tonight is purple and yellow, the bright yellow. There's also kind of an orangey yellow. So purple and bright yellow, that's looks and events. And then we'll look at the others another time. So this is also a way to kind of pare down. So in terms of looks, right off the bat, the first block here, when you look at it, it literally says, say hello for 2 seconds. Plain English. And that is literally what the block will make your sprite do. So if that's what I want it to do, I'm going to grab that, just click on it, and I'm going to drag it over here into my programming window and just drop it. So that is now a bit of code that is attached to this sprite. If I want to see it work right now, I just click on the block and it will run. It says hello, 2 seconds, it disappears. I know it's kind of small. Let me just make this a little bigger for a second. It says hello, and then it disappears. So I've just programmed my first program because now it's interactive. When I click on that bit of code, my sprite says something, and then 2 seconds later it disappears. In any of these blocks where there are these white circles or ellipses, that's a place where you can change the parameter. So maybe instead of hello, I want it to say Guten Morgen if it's German. All right, changed it. Now when I click on the block, my cat says Guten Morgen. All right, maybe I wanted to say it for 5 seconds. I changed the 2 to 5. Now when I click on it, it says Guten Morgen for 5 seconds, and then it disappears. So essentially every block functions like that. It's a single instruction. The instruction, when you click on it, will do what it says it does. Sometimes that's something that happens visually. Sometimes it's something more that just happens in the background. But that is the basics of how the programming works in Scratch. If I want it to do more than one thing in a row, I grab the block and I drag it out and I click the blocks together and they will snap together. When you get them close, you'll see that gray, and when I let go, it snaps the 2 blocks together. So now I have 2 instructions where the first instruction will run and then it'll immediately follow the second instruction. So I'll say V Gates, and I'll have it say that for 4 seconds. So now when I click on this, it'll do the first instruction, Guten Morgen, 5 seconds. And then for 4 seconds, it'll say V Gates. And you can see my code has a little yellow outline while it's running. That just tells you something is running right now. And that's that. So building code is basically just about finding the instructions you want, dragging them into the programming window, and if you want multiple instructions to happen, you click them together. Now I can have other blocks of instructions. So for instance, the next 2 are think, and the only difference with thinking is that it puts it in a thought bubble instead of in a speech bubble. So if I pull think out here and I don't snap it together, this is now a separate instruction that I can run separately. So I can just click on it and the cat will just say hum for 2 seconds. Or if I click on this one, it goes back and runs that one. So each sprite can have as many different little sets of instructions as you want. So you're making a game board. Maybe a sprite needs to move right 4 spaces, or it needs to move left 4 spaces, or up 4 spaces, or down 4 spaces. You can set that up as 4 different sets of instructions. And when each one is run, the sprite will do that thing. So that's basically how all of this works. All right, does that make sense? It's meant to be very visual and as much as possible in plain English. So if I just read this like it was a paragraph, it says, say Guten Morgen for 5 seconds, say V Gates for 4 seconds. In plain English, that describes exactly what the sprite is going to do. So they try to do that. So now I think relatively quickly, I can go through the rest of these purples because again, they pretty much all do exactly what they say. So you've got the say and the think. What I should say is the ones that just say hello or think something. When those run, it will stay there forever. If you want it to go away, like right now he's saying hello. If I need it to say nothing, I'll put in a say and I'll make the say blank. And then when I click on it, that'll make the speech bubble go away. Otherwise, it will say hello forever for as long as the program's running. So that's just a little quirk with those. So say and think. You can't control the size of the text or anything like that. It does all that automatically, but it's an easy way to get a sprite to do some dialogue. Then you get a series of instructions that are all about the costumes and the backdrops. And again, they do exactly what they say. So the first one says switch costume to, and then there's a pull down. And it will give you a list of all the costumes that that sprite has available. So I could say switch to costume 2. When I click on the block, it switches to costume 2. Yes, I went in and altered the sprite, the scratch cat a little bit during the break. So now he looks a little scared and surprised. All right. Or I could have it go back to costume one, run it, it goes back to costume one. The ones that just say next, again, they do exactly what they say. When it gets clicked, it'll go to whatever the next costume is in the list of costumes. So that's a way to very quickly go through a whole series of costumes. I'm just clicking next, 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 next. If it gets to the end, it loops back to the beginning of the costume. So a lot of times when you see a character animate where it's walking, it's just going through a series of costumes one after the other in kind of a loop. So that's that. And then there's two for the backgrounds too. So if you have multiple backgrounds, you can also switch to a particular background or just switch to the next background. So that's a set of them. These next ones are all about now changing some of the characteristics of the sprite. So I can change the size. So I could say change size by, that means it'll take whatever size it is now, and then it'll either increase it, or if you put a negative number in, it'll decrease it. So right now, every time I click this, the cat will get bigger by 10%. Oh, he's getting closer, he's getting closer. Put in -10. Now every time I click it, it gets smaller. So that is something that you can code. You can also just set the size to a certain value. So if you don't want to just increase or decrease and just say go right to size number 5 or whatever, you can put that in as well. And it even says set size to blank %. You fill that in. You can also change to a certain extent. They have a couple of effects that are built in. So there's a color effect where it'll attempt to recolor the sprite in a different color. That generally works better when the sprite is all one color to begin with. And then there's a series of other effects that kind of warp the image some. So like there's a whirl effect. And when I click on that, the Sprat Cat starts to go into a whirlpool shape. Oh, sorry, Sprat Cat. He doesn't look very comfortable now. There's a ghost effect, and that's really transparency. So that gradually makes the sprite get more and more transparent. So you can kind of make things fade out by making them get more transparent. So you've got that, and you can pick which of the effects you want, and then how much you want it to change by. Or again, you can just set a particular effect to a particular value. So maybe that ghost effect, I want to get rid of it. I'm going to turn it back to 100. Oops, that means I need to set it to 0. So now Sprat Cat is back. Or I could change the color effect to 20. And now Sprat Cat's kind of green instead of orange. Right? But the nice thing about these is they're not changing the costume. This is an effect that's added on top of it. So the costume hasn't been changed. And you can always go back to it by just saying clear graphics effects, and it'll take it back to its regular costume. And that's another one of these blocks. And then the last 4 here, again, all of these pretty much say what they do. You have a show and a hide. Running out of space here. And those do exactly what they say. I can hide the sprite. I can show the sprite. And you can build that into a program. And then the last 2 have to do with that idea of layering that we were talking about when we were drawing the sprites. The sprites themselves also are in layers. So if you have a lot of objects on the screen and you need one of them to be behind the other one, then you can use these, and you can either say go to the front or the back layer, or you can also move them forward or backward one layer at a time. So I don't know, if you have a whole bunch of playing cards on the screen that are all overlapped, if somebody turns over one of those cards, you might need that sprite to come to the front as it does so. But again, those block instructions just do exactly what they say. And those are all of the look things. Those are all of the purples. For now, you will see in some of the categories, these that are a different shape, they're in ovals. Don't worry about those right now. That gets into something we'll talk about down the road when we start talking about variables and some other things. For now, just look at the ones that kind of have that block shape where they obviously snap together. So these are all things that you can put into a program, and either, now that these are all in here, each time I click on one of them, it'll do that thing, so I can just kind of go through them and click on each one at a time and have it do each of those things. Or I could, as I showed, you can combine a whole bunch together and have a whole series of instructions run just by clicking on the block of instructions. So is that relatively clear in terms of how those work? I think Scratch does a pretty good job of turning programming language into plain English. So when in doubt, just read what the block says and kind of listen to what it says, and it should pretty much give you the information that you need in terms of what that particular block does. I should point out, if you need to delete a block, if the block is all by itself, the easiest way to delete it is just to drag it back over to the left. And when you do that, it'll just kind of disappear it. You can also right click on a block and you will get duplicate or delete. So if you need a whole bunch of the same one, you can also just do it by duplicate, duplicate, duplicate. But that's also a way to delete a block by doing it that way. Be careful if blocks are connected together. Sometimes they behave a little weird. If I say delete block, oh, that time it worked okay. I've sometimes had it where blocks are connected, and when you delete a block, it kind of deletes a whole series of blocks that are all connected. So sometimes you have to disconnect the blocks apart, delete the one you want, and then put the remaining blocks back together. Which again is kind of like Legos. You need to get rid of that red in the middle. You've got to separate it out, get rid of it, put the other ones back together when you're done. All right, so that's all of the looks. That's all of the looks blocks. That's in terms of the mini project this week. Those are all of the things that you'll be using in terms of getting your sprite to do certain things. The other category I want to look at, which is a much shorter category, is the events category. And these don't tell your sprite what to do. These tell a piece of code to run. Right now, I've been running them all by clicking on them. But obviously, if somebody's using your program, they're not going to be looking at the code and clicking on bits of your code to get things to run. They're going to be out here and they're going to be clicking on the cat or clicking on the dog or pressing a key on their keyboard. And so we want to be able to run all of these instructions by sort of remote control, if you will. And that's what events are. Most of the events have this little curved shape on the top. They call it a hat or a top hat. And the reason that they're that shaped is this has to be the top instruction. These have to go at the top, and then the instructions go underneath, or the code goes underneath. So these are meant to sit at the top of a stack. So let me go back to that Guten Morgen. And let's say that I want this to happen when somebody clicks on the sprite. All right, that seems reasonable. They're in here. I want them to do something. I click on them. So when I look at my possible events, one of them literally says, when this sprite clicked. I guess they could have put the word is in there if they wanted the English to be a little better. But it says, when this sprite clicked. I drag that and I click it on top of this. So now if I read this as a paragraph, it says, when this sprite clicked, say Guten Morgen for 5 seconds. And that is exactly what will happen. I come out here, I click on Mr. Cat, says Guten Morgen for 5 seconds. and then it goes away. And I knew it was running because over here, the code got surrounded in yellow. That's the way of showing me that that's the bit of code that's running right now. So I now have made a remote control for that piece of code. I've now made the cat interactive. Now my user does something to the cat and the cat does something back. And that's kind of the whole point of code, is to get things to do things when users tell them to do them. So, the other ones, again, they're all relatively self-explanatory with maybe the exception of the last one, which I'll talk about a little separately. There's when the green flag is clicked. The green flag has a special place in Scratch. That is the start button. That is the way people will start your program when they go to the project page. In here, we have the green flag sitting up at the top so we can test it. So usually green flag instructions are the things that need to happen right when the program begins. So it's usually a lot of putting a sprite in a particular place, or resetting a scoreboard, or moving things back to a start position. Those kinds of initial activities. Generally, once a program's running, then you don't push the green flag again, because then that'll restart the program all over. But you have that as an option, as a way to start something. So, I could have it say hello when I click the green flag. Click the green flag, says hello. Now I need to get rid of it. Bye. The next one is if you want keyboard interaction. It starts off by just saying when space pressed, or space key pressed, but when you pull down the menu, you've got all 4 arrows, up, down, right, and left. You have an option for any. Be careful of that, because that literally means anytime they push a key, this will happen. And then it just goes through the alphabet and the number keys. So you can't use like the special keys or like the punctuation keys. It's only the letters, the numbers, the arrows, or the space bar. But generally speaking, that's usually gives you enough. So this would be a way to have something different happen depending on what key they press. So maybe I'll use the up arrow. And where's that change size? So I'm going to put my change size I'll go back to making it get bigger. So now when I push the up arrow, cat should get bigger. All right. If I want them to get smaller, then what I need to do, actually, I'll do a duplicate. So now I've got a second copy of those 2 instructions. I'll change the up arrow to down arrow, and I'll change the positive 20 to minus 20. Now when I click the down arrow, cat gets smaller until he goes away. All right. So that one is really useful because you really get to determine what the key interaction is on the keyboard. So when the flag, when the space bar, when the sprite is clicked, you've got all 3 of those. This next one is when the backdrop switches to. I personally have never used that one. Where I guess it's useful is if you have like a multi-stage game, that maybe you set it up so that when you go to a certain backdrop, certain sprites turn on or something like that. So it's there. I've personally never used it, but you link it to one of the backdrops, and then whenever that backdrop becomes the active backdrop, then that instruction will run for this sprite. So that's just another option. Another one I've never used is this one. You can choose between loudness or timer. But, again, that just means, if a timer gets started, when that timer reaches a certain count, then it will execute this instruction. Loudness, that requires the interaction through a microphone. That's not always reliable. So I've never personally used that one. And then the last group here, and this is the last thing for tonight. So these last ones have to do with messages. And what messages are is they're like having a back channel of communication inside your program so that sprites can talk to each other without the user's involvement. So, for example, I might want to have something that when this dog gets clicked on, maybe the dog moves, gets bigger, and the cat changes its costume into that surprised look. So what I would do there is on the dog, I would have a when this dog clicked, and I would tell the dog to get bigger, and I would maybe move the dog to another location. But then I would also have the dog broadcast a message, and I can decide the name of that message. It doesn't really matter. It's not an actual text message, it's just a name. So let's say the message is surprise. Then on the cat, I would have this one which says, when I receive message, and I'll just leave it as message 1, go to costume 2. So it's not that the cat's interacted with, it's that one of the other sprites says, oh, that other sprite should do something. So I'll demonstrate this really, really quick. I'll go to my dog. I'll say when this sprite is clicked, I'll go back to my looks and I'll just say set size to, let's make it super big, 400, and broadcast message 1. So when I click on the dog, dog's going to get really big, and the dog sprite is going to send out message 1. And it's okay that it's called message 1. Scratch Cat is going to receive message 1 and is going to switch to its second costume. Let's see if it works. Here I go. I'm going to click on the dog. Oop, it worked. Dog got huge, cat got scared. So those two sprites just talked to each other in the background. You can set up as many messages as you want. If you want different things to happen. If you want a different one, you click on this and you just say new message. It'll ask you what you want to name the message, and then you can use that anywhere else in the program too. So that's just a way to have sprites send triggers to each other. Is that. All right. So to boil it all down, to simplify it, what we did tonight was get an introduction to the basic Scratch platform. We learned how to make pretty pictures, sprites, backgrounds. Sprites can have multiple costumes. You can have multiple backgrounds. We learned how to draw them. We learned how to kind of work with that. And now we also have this introduction to coding where we can start to make those sprites do things by building a set of instructions and then triggering that set of instructions through a variety of different ways. So that is as far as we're going to take Scratch this week. Questions? All right. What I'm going to do in the interest of time is, rather than giving you some time right now to try this out, I'll just encourage you over the next day or so to find a little time to kind of go through this stuff. And any questions you have at all, just send them right to me and I'll try to get back to them as soon as I can and help you out. But I think the more you play with it, the more it's going to make sense, right? You can basically just say a set of instructions in your head and then find the blocks that say the things that you just said you wanted to do. Like you just heard me say, when I click on the dog, I want the dog to get big and I want the cat to look scared. That was my sentence. The coding was, when this sprite clicked, change size to 400%, send this message out to the cat takes the message and goes to its surprise costume. So basically I'm taking a plain old English description and I'm just turning it into a series of messages. So that's really all that this coding is about, is finding the right blocks, snapping them together, and then having them do things on the screen.